Okay, so let us look at another question. Right, question number 5. Okay, so let's remove this so that I will have flexibility, right? So now at this point, number 5, this is number 5. Okay, so show that the area of a surface generated by revolving the curve, which is x is equals to the square root of a squared minus y squared. Okay, where there should be a 0, y, and then a divided by 2, right? Now right over here they said something that a is positive. Okay, a is positive, is a positive constant, right? A is a positive constant, right? So about y-axis, so y-axis is pi a squared. So we need to show that. Okay, so let's just carry on. This is just an easy stuff, I guess. Alright, so the first thing that you have to do is find the derivative of that. So that should be your dx divided by dy equals to, so right over here this should be written as, okay, that should be your a squared minus y squared 1 over 2. Okay, I hope you see that. Alright, so moving on, if we take the derivative of that, so we're going to have 1 over 2 a squared minus y squared, and then 1 over 2 minus 1, so it is going to be negative 1 over 2, right? And then multiplied by the inside part, right? Remember they say that a is a positive constant, so which means we're going to have to derive this, so we will have minus 2y, right? That's what you're going to have. Okay, so now when we clear out everything perfectly, so this should be, so this 2 is going to cancel out that 2, and then you're going to be left with minus y divided by the square root of a squared minus y squared. Okay, that's what you're going to have. Right, now let us move on. So this is the area of the surface, right? So this is going to be equals to 2 pi, right, antiderivative from 0, right? That this is the condition that we have from 0 all the way to a over 2. So a over 2. Alright, so we're going to have x multiplied by the square root of this, right? The square root of 1 plus that. Okay, so in that case, since we have this, so we should be negative y divided by a squared minus y squared. There should be a square root squared, and then dy. Okay, so now let's quickly solve that. So right over here we have 2 pi 0 to a over 2, right? So about your x is this, so we should put it a squared minus y squared. Okay, so multiplied by the square root of 1 plus, this should be y squared divided by a squared minus y squared dy. Okay, we will have something like this. Alright, so now let us carry on. Suffix area is going to be 2 pi from 0 to a over 2, the square root of a squared minus y squared. Let us solve this inside part. So denominator is going to be that. That's going to be a squared minus y squared plus y squared dy. Okay, so the surface area is going to be equals to, the area of the surface, not a surface area, is 2 pi, and then 0 to a over 2, root of a squared minus y squared, multiplied by, that should cancel out. We should have to just jump some steps. So there's going to be square root of the top of a squared. It should be a divided by the square root of the bottom, square root of a minus y squared. You're going to have something like this, okay? And then dy, this would cancel out this, okay? So now the only thing that you will have is that the suffix area is going to be equal to 2 pi 0 to a over 2 of your a dy, okay? So now you know exactly that suffix area is going to be equal to 2 pi into, so this should be your a squared divided by 2 integrated from 0 all the way to a over 2, right? So now you plug in everything, right? So this should be 2 pi into, that should be your a over 2 squared over 2, right? Probably there should be a minus a 0, okay? So in that case you're gonna have that, okay? Oh, probably I just made a mistake right here. Okay, so here this should be 2 pi of, so that part, so probably we must have a squared over 2 on that part, okay? Because you just plug it right over here, and then after that we just solve everything, right? So that would cancel out. We're going to be left with pi a squared. That's what we're trying to solve for.